To be able to use the CMN-700 performance application, you must associate a compatible version of Performance Model library. This library should contain a compatible version of the performance model. To associate the performance model, select Performance, Associate Model Library. In the Associate Performance Model Library dialog, browse and select the location directory for the extracted ARM Performance Models library to be associated. Click Associate. A green tick symbol appears beside the Associate Model Library menu item to show that the association has been a success. You can run simulations of CMN-700 using a dynamic model that matches your configuration to evaluate the performance of your CMN-700 and potentially drive the architecture refinements. The latest version of the CMN-700 Performance Flow enables you to configure and run two different types of performance data configuration setups. This allows you to investigate the expected performance of CMN-700 configurations. The two modes of performance configurations for CMN-700 are single CMN-700 mesh mode and multi-CMN-700 mesh with coherent multi-chip link mode. Some examples of the types of performance configurations that are supported by the CMN Performance Flow are a single CMN-700 socket configuration, a single CMN-700 socket configuration using memory-attached CML links to CCG devices, symmetric two-socket CMN-700 configurations where both sockets are the same mesh design, asymmetric two-socket CMN-700 configuration where each socket has its own mesh design and potentially the two sockets are run at different clock rates. To enable you to get started quickly on the CMN-700 performance application, it now includes several performance configuration samples. You can load this into the tooling to allow you to review and run samples on performance configurations for CMN-700. To import those samples, click on Performance and click on Import Performance Data. And we have the four samples. The first sample we have is the sample 2x2 CCG perf test chip. And this is a single mesh configuration that demonstrates using CCG nodes in a SAM mode. One test case uses non-coherent traffic and the other uses coherent traffic. And second one we have is the asymmetric two-chiplet perf test. This sample shows two different mesh designs connected in the CML system. The test cases include running local traffic only, running remote traffic only, and the one-to-one mix of remote and local traffic. The third one we have is the symmetric multi-chip realistic perf test. This sample shows two instances of same mesh design connected together in a CML configuration. The test case contains a snippet of sample workload that shows performance benefits with the HNS configuration. And the fourth one is the symmetric two-chiplet perf test. This sample shows two instances of same mesh design connected together in a CML configuration. The test case contains a one-to-one mix of local and remote traffic. To add the performance data to your configuration, select Performance and Add Performance Data. In the Associate Performance Data dialog, select the project to which you want to assign the performance data node. In the Configured IP Types field, select CMN-700. Select the IP version from the available version listed. To enable single mesh mode, leave the multi-selection checkbox set to false. If the multi-selection box is set to true, the multi-mesh mode is active. In the Matched Configured IP field, either for a single mesh mode, select the CMN-700 instance. For a multi-mesh mode, select more than one CMN-700 instance to reference and click OK. A performance data node is added to the project in the Project Explorer. A performance data node with the prefix of MC denotes a root node for a multi-mesh instance mode. The project where you have created a multi-mesh performance data node does not need to contain any other data, such as the reference CMN-700 configurations. Double-click on the performance data to display the Overview tab. The Overview tab displays information about the configuration reference. This information is a snapshot of CMN-700 configuration taken when the performance data node was added. The Overview tab differs for both a single CMN-700 mesh instance and the multi-CMN-700 mesh instances for performance configuration. With the single mesh configuration Overview tab, you can review configuration reference details for the CMN-700 IP configuration. You can review all interfaces available on the CMN-700 IP configuration, and you can see which interfaces are supported by the CMN-700 Performance Flow. Also, you can configure reference to be relinked and refreshed to pick up any relevant changes in the referenced CMN-700 IP configuration. You can also set the HTTP hashing mask and the region compare mask values. If the current component specification and performance data do not match the configuration reference, you cannot run test cases. To resolve this problem, click Assign the source configuration reference to update the configuration reference. For a multi-mesh performance configuration, in the Overview tab, for a root performance data node denoted by the MC prefix, you can review the list of configuration references and their details for all the referenced CMN-700 configuration. And you can also review the list of instances of the configuration reference for each referenced CMN-700 configuration. And you can also open the editor for child performance data by double-clicking on the instance in the existing instance list. For child performance data, you can also review configuration reference details, and you can also review all interfaces available on the CMN-700 IP configuration. And you can also set the HTTP hashing mask and the region compare mask values as required. The editor for multi-mesh performance configuration contains additional pages compared to a single mesh configuration. The three extra tabs are Layout page, CML Links, and Instance. In the Layout page, we have a canvas and a palette. You can drag a referenced configuration from the palette section on the Layout editor onto the Layout canvas. The palette section contains an object to represent each of the referenced CMN-700 mesh component. When you drop a reference configuration onto the canvas, a representation of the referenced mesh is created. Every time you drop a referenced mesh onto the layout canvas, a new mesh instance or a child performance data is created. You can double-click on the canvas instance to see the mesh instance details. To create the CML link between the two CCG interfaces, you can use the connection tool from the toolbar at the top of the layout canvas. In the CML Links tab, you can manage the CML links. You can set and manage various performance configuration properties of a CML link from the CML Links editor page. You can also add or delete CML links from the CML Links table. For each CML link, you will be able to set the parameters that's shown in the CML Links page, and the CML Links table is updated with newly created CML links, and the new links are also visible in the Layout page of the Multi-Mesh Performance Data Editor. In the Instance tab, you can view a list of mesh instances created using the Layout editor. On the middle left here, we have Instances tab. This is a list of mesh instances in this multi-chip configuration. So for each instance, we have the instance details, and you can also change the name of the instance. We also have the reference mesh details of instance. On top of that, we have also CCG info of each instance. You can double-click on an instance in the list to open the editor for that instance. A system address map in the CMN-700 Performance app is composed of address regions, each targeting one or more nodes. The number of HTGs, hashed target groups, is determined by configuration mode for system address map. A system address map requires you to add a set of memory regions, define the mappings between each set of devices and each HTG. You need to create a system address map for the CMN-700 Performance Flow because elements later in the flow depend on its contents. For a single mesh performance configuration, you only need to define one. For a multi-mesh performance configuration, you must define a system address map for each instance of the reference mesh configuration. To set a number of hashed target groups, you need to go into the hashed target groups and hashed target group device selection. On the HTG selection tab, select the configuration mode from the available option. Each type of configuration mode has a limit of number of HTGs that can exist for a system address map in the CMN-700 Performance Flow. On the HTG selection tab, select the configuration mode from the available option. Each type of configuration mode has a limit on the number of HTGs that can exist for a system address map in the CMN-700 Performance Flow. If a single is selected, then only one HTG can exist. This is the default configuration mode. You cannot add or delete any HTGs in this configuration mode. If quadrant is selected, then exactly 4 HTGs can be defined. You cannot add or delete any HTGs in the configuration mode. If custom is selected, then up to 32 HTGs can be defined. You can add or delete HTGs to and from the list using the buttons provided. Using the toolbar at the top of the visual representation of the CMN configuration, you can edit the contents of the hashtag groups. Select either the add icon or the delete icon to put the editor into either add or remove edit mode. In either add or remove edit mode, you can add or remove device from the selected HTG. After finishing configuring things in the device selection window, go to the Details tab. In the Details tab, you can set a hashing type of an HTG. The HTG hashing type has an impact on the content of an HTG and the type of default mapping options available. You must set the required hashing type for the HTG. Each HTG must contain at least one valid memory region. The maximum number of allowed memory region per HTG is 2. Default memory region is added to each newly created HTG. Use the icons next to the memory regions to add or delete memory regions. The next window we have in the Details tab is the HN to SN device mappings. For HN to SN mapping, each of the HN devices must be mapped to one or more SN device for an HTG, based on a combination of the hashing type and the mapping function of the HTG. All the previous things that we mentioned in the system address map section were the required settings that you had to make for a performance application to work. But we also have a lot of optional settings and parameters that you can set in the performance model. For example, in the system address map settings, we have the prefetch memory regions and the QoS regions and description section. On top of these options, we also have 2 more tabs. First one for the non-hashed target group. You can add or delete up to 8 memory regions. We also have a window for HNI programming. The Profiles tab. Source Performance Traffic Profile defines a traffic pattern that can be generated by a device into the connected target interface. You associate the profile with one or more target interfaces in a test case. When you run the test case, the target interface generates traffic according to the profile. There are two types of source performance traffic profiles: AXI traffic profiles and CHA traffic profiles. The source performance traffic profile enables you to define a particular traffic pattern. To add the traffic profile to your performance data, in the Source Profiles table, in the Profiles tab, select the tab for the type of target that you want to create. We'll go with AXI in this example. Click on the plus icon and bring up the Performance Data Manager. Enter a name and description for this profile. Configure how traffic is generated when you run a test case. And click Next. In the next page, configure the AXI or CHA transaction types to be generated and their proportion of the total traffic. The first thing we can configure here is the MTE support level. Select the level of memory tagging extension support that you want the profile to use. Use the Add, Delete, and Clear buttons to populate the traffic transaction type list with the different transaction types you want to use. The percentage values used for transaction types must be equal 100%. By default, each type is allocated a 10% share. You can manually edit this value. You can use this icon to automatically calculate the percentage of the transaction types. And click Next. On the next page, we will configure the address ranges to be used by generated transactions and the pattern in which they are used. For the address pattern, we can use sequential or random. Sequential means a single sequential address range, which is used by all transactions. Random means a set of address ranges and their proportion as a percentage of a total address generated. The address ranges are used randomly by individual transactions based on these percentages. All configured address ranges must be compatible with the memory regions defined in the system address map. Next to the source profiles, we have the target profiles. When you run the test case, the target device handles traffic received from the initiator interface according to the profile. So similarly to the source profile, you associate the target profile with one or more initiator interfaces in a test case. So for the target profiles, we have 4 different target profiles: the AXI target BFM, an AXI ideal memory, and CHI ideal memory, and CXL memory. So the first one, the AXI target BFM, this accumulates requests and generates a response after a delay equal to corresponding read or write latency. We can add or delete and configure them. The AXI ideal memory and the CHI ideal memory and the CXL memory, they're all same. They all behave like a memory controller with an ideal access time to memory. So you can give it name and description, and you can set the buffer size of the memory, and you can enable the DRAM efficiency and the DRAM clock frequency and memory latency and memory latency variance. Creating a traffic profile groups. Traffic profile group contains multiple source performance traffic profiles. You associate the profile group with one or more sources in a test case. So when you run the test case, the target interface generates traffic simultaneously for every profile in the group. A traffic profile group provides a way of modeling complex traffic scenarios by combining multiple source performance traffic profiles. For example, you could build a group to model a scenario where a profile A models a constant traffic stream, whereas profiles B and C to capture 2 different types of traffic bursts that appear periodically at different times. You can use the add and copy and delete icons in the middle to manage the profile groups. So the next tab we have is the Runtime Options. So you can create a set of runtime options if required, but keep in mind that these are all optional to a test case. The first tab we have is the HNF. So this tab is used to set a range of quality of service values for each QoS class in the HNF and the number of entries allowed for each class in the point of coherency queue. The HNF QoS class tab, you can edit the values of several parameters. This tab also contains 4 class tabs: high, medium, and low. These enable you to configure a set of parameters on per class basis, and there is also a tab to you to set the miscellaneous weights. Next tab is the QoS Regulators. So in this tab, you can configure a QoS regulation settings on an RNI or MXP devices in the mesh. You can create the QoS regulator and assign it to a specific test case. Use the add, copy, and delete icons to create and manage your QoS regulators. And you have the QoS regulator details window to show you each RNI and the cross points in your configuration. The third one we have is the deadlock detectors tab. So deadlock detectors set a timeout limit in cycles to consider transaction deadlocked. The performance model throws a fatal error when this limit is reached for a transaction. You can use the gear icon on top right to assign the same value for every instance in your configuration. In the double channels tab, you can specify the devices in the mesh that send data and responses on channel 1 when double data, request, response, and snoop channels are enabled in the mesh design. There are 4 panels used to apply settings for each channel separately: DAT, RSP, REQ, and SNP. On the Double Channels tab, select the devices that are to send data and responses on channel 1. After that, we have the Memory Partitioning and Monitoring tab settings. So you can define MPAM settings to partition and monitor memory system resources. Next one we have is the non-XY routing. Specify a route overrides between pairs of start and end devices in the mesh. These routes override the default XY routing of the mesh. The RNI and RND properties. You can change the properties for RNI and RND devices from the reference CMN-700 mesh component. The last one we have is the CCG Properties. You can change the properties for CCG devices from the reference CMN-700 mesh component. Creating a performance test cases. Test case associates source and target performance profiles with target and initiator interfaces. You can create multiple test cases, each containing different combination of interfaces and associated traffic. You can use these test cases to build up representative test suite, which to simulate, analyze CMN-700 performance. In the Test Cases tab, click Add. The Performance Data Manager wizard is displayed. On the Test Case Details and Properties page, enter a name and description for this test case. Define the sim time and warm-up time properties for this test case. Optionally, set a new clock frequency to apply to the case. Optionally, assign a previously defined QoS regulator to the case. Optionally, assign a previously defined deadlock detector to the case. And click Next. On the target interface mapping page, for each target interface that you want to use, select the traffic to be used. On the Initiator Interface Mappings page, for each initiator interface that you want to use, select the traffic type and click Finish. Now the test case is added to the list of test cases in the performance data table. The details of the target and the initiator interface mappings are shown in the test case interface mappings table. Test cases must be run individually, one at a time. Each run generates a set of results which you can view in tabular and graphic form. Click Run to run the test case. If the test case run completes successfully, you can view the results. Progress and the completion status of the test run is displayed in the console. Any errors that occur are, where appropriate, flagged in the appropriate project screen. Results from the last execution of the test case can be viewed as a set of statistics in tabular form. Each statistic is displayed in its own row in the table. The entry in the description column explains what the statistic means. When a test case is run, the results are stored in the file shown in the results search path. A subsequent run of the same test case overwrites the contents of that file. From the test case name dropdown, select the test case for which you want to see the results. If valid test results exist, they are displayed in the test case results section. You can filter the test results using any combination of the following: the component name, component type, statistic category, and results filter. The Results Context tab provides a graphical view of the test results, using a simplified view of the devices, cross-points, and cross-point connections defined in the architecture for the target interconnect. When test results for a test cases are shown on the Results Statistic tab, the same results are also shown graphically on the Results Context tab. The Results Context uses the same layout as the Canvas interface that is used to create and edit the CMN-700 IP configuration. Using the same layout provides a common context and makes it easier to identify components. The devices are shown as boxes, each of which contains the device type. Different types are shown in different colors. The instance name, the value of the currently selected statistic as defined in the component filter. If the instance has no value for that statistic, the box and its contents are grayed out. Cross-point connections are shown as lines. The value of the currently selected statistic, as defined on the link filter, is shown in the middle of the line. If the connection has no value for that statistic, the circle and its contents are grayed out. Navigation and search controls are provided above the canvas. You can pan around the canvas and zoom in and zoom out. Okay, so last thing we're going to cover in this video is that you can export the performance data project to re-import it later. So you just have to go to Performance and click Export Performance Data and select the project that you want to export and give a zip file name and click OK. When you export a multi-mesh project, you must select to include all projects that the multi-mesh project references in the export dialog.